Hi guys, so today we're going to start looking at what a matrix is. So a matrix is really just a rectangular arrangement of numbers that you can use for different purposes. But the way you arrange those numbers is into rows and columns. The next part's really important. It says the dimensions of a matrix are listed as the number of rows by the number of columns. So the way we list matrices is the way we call their dimensions is that we would say it's something like a 1 by 4. That would mean there was 1 row and 4 columns. Or if we say it's a 2 by 3, then it would have 2 rows and 3 columns. So the first number is rows. So it's rows, then columns. Each number in a matrix is called either an entry or an element. And then each space in the matrix you can identify using this notation. So you have A, and it's hard to see with that little misspell line. It's A with a little subscript I and J. The I is the row number, and the J is the column number. Again, following that order of rows and columns. And then typically when you name a matrix, you use just a capital letter. So down here in example 1, matrix A. So capital letter A, and this is showing us the example of what a matrix looks like. So this would be, there are 2 rows and 3 columns. So 2 rows and 3 columns. So that's a 2 by 3 matrix. And then it's hard to kind of see the notation there. It's got kind of those square brackets around it. All right, so what's in spot A21? So the second row and the first column would be spot 4. The next one's asking for row 1, column 3. So row 1, column 3 is 0. All right, so something that's good for matrices is to use it just for data. So something like the data in this chart, I could just rewrite this as a matrix and just use those values, and then perform whatever operations I would need to perform. So the dimensions of this matrix, there are 3 rows and 2 columns. Entry 3, 2, that is the third row, second column. And that just represents the cost of a 9-inch tuna sandwich. The address of the entry, that's 595, so 595 is up here. That is the first row and the second column. Again, it's rows and then columns. So this is row 1, row 2, row 3, column 1, column 2. Rows are horizontal, columns are vertical. All right, so now we're just going to do some basic operations. So starting with addition and subtraction. So addition and subtraction is pretty easy. It's exactly how you think it should be. They have to have the same dimension, however, in order to be able to add them together. And then all you really do is you take whatever's in the same spot and you add or subtract them together. So if I'm doing W plus X, then I'm doing this matrix plus this matrix. And then the entries that are in the same spot get added together. So this becomes 17, negative 15, 6.5. Oh, I'm multiplying. Whoops. 17, negative 8, 6.5, 7, negative 4, and 13. Y minus X, I would just again subtract those entries. So 10 minus 10, 6 minus 6, 17 minus negative 4, 4 minus negative 5, negative 5 minus 3, and 0.2 minus 7. Whoops. Negative 6.8. All right, down here in C, again, there's just 3 operations. I'm going to do X plus Y minus Z. So I'll start with X plus Y. So X plus Y would be 20, negative 1, 12, negative 2, 13, 7.2. Then minus W. So 20 minus 7. Negative 1 minus negative 3 becomes negative 1 plus 3. 12 minus 1/2. Negative 2 minus 4. 13 minus, was that 6 or 0? Let's see, that was W, so 13 minus 0, and 7.2 minus 6, which gives me my final answer. All right, when I get to y plus z, if you look, those have different dimensions. Y would be a 2 by 3. Z is a 3 by 2. You cannot add those two things together, so there's no solution here. All right, so the next two we're going to look at is an example of scalar multiplication. So this is not the same as multiplying matrices together. That's a little bit harder. We'll do that in a second. But if we multiply by a constant, again, pretty simple, kind of like distributing almost. So this means that the number 2, that's the scalar, is being multiplied by z. So I'm going to do 2 times this matrix. And all I do is I take every entry and I multiply every entry by 2. So I would end up with 2 times 3 is 6, 2 times negative 5, 2 times 10, 2 times 0.3, 2 times 7, and 2 times 15. All right, go ahead, pause the video and try this last one. All right, so starting with 3x, so I'm going to multiply every entry by 3, so that's 30, negative 15, 18, 9, negative 12, 21, 2y. So 2y is going to be 20, 8, 12, negative 10, 34.4. And then just subtract negative 10, 6, negative 46, negative 23, 19, and 20.6. All right, so now we're going to look at multiplying matrices together. So this is going to be a little bit tougher because, first of all, there's some new rules here. You cannot necessarily multiply matrices just that have the same dimensions. There are other matrices that you can multiply together. Now, what has to be true in order to know if you can multiply them together? The columns of the first must match the rows of the second. So if I were to write this out, like let's say this one was m by n, and then the next one would have to be n by whatever number. So these middle numbers here have to match up whenever we write it. The result will be the rows of the first, which would be this number, and the columns of the second. So if the middles match, the result is the outsides. So for example, if I multiply a 2 by 3 matrix by a 3 by 2, yes, I can do it because those match. The result would be a 2 by 2. If I have a 3 by 4 by a 4 by 1, yes, I can do it because the 4s match. The result's a 3 by 1. 1 by 4, 4s match. I get a 1 by 2. Now, let's look at this. It's the same matrices. It's still a 1 by 4 and a 4 by 2, but I'm changing the order. And now when I change the order, I can't actually do it because those middle ones don't line up. So this is no solution. So what's important to note here, that commutative property that you're used to, like 2 times 4 is the same thing as 4 times 2, that does not work with matrices. Just because you can multiply, let's say this was matrix A and this is matrix B, you cannot necessarily do B times A. It completely depends on what those dimensions are. So be careful about that. The order here does matter. All right, so multiplying a 3 by 2 by a 2 by 3, the middles match, so my result would be a 3 by 3. So now let's look at the actual process of multiplying a matrix. So I'm going to start just by showing you where the results will go, and then we'll look at what the process is. So what we do is we match up, again, the row of the first with the column of the second. So I'm going to take the row of this first one, and let me get a little bit of a smaller marker there. Okay, so I'm going to take the row of the first, and I'm going to multiply it by the row or column of the second. So the answer, whatever operation I do, is going to go in the first row, first column. Then if I take the row of the first times the column of the second, that's going to go kind of at the intersection of those two, the first row, second column. All right, if I did the row of the second row in the first column, that's going to result row 2, column 1. And then finally, if I do row 2, column 2, that would go over here. Okay, so that's where your answer is going to go. Now, what we do with those numbers, we're going to match them up. So, like, let's start first row, first column. Okay, first row, first column, I would take 1 and A, I would take 2 and B, and I would take 3 and C. I multiply those all together, and then I add them. So I would do 1 times A plus 2 times B plus 3 times C, and that would go in that spot. Then I would go to the next one. I'd go row 1 and column 2, multiply 1 times D, 2 times E, 3 times F, and add them together. And I just continue that pattern until I'm done. So let's try one now with actual numbers. So first of all, let's make sure it's possible. This is a 2 by 3. This is a 3 by 2. So yes, it's possible. The result is going to be a 2 by 2. So what I do to start, I'm going to take row 1, column 1. So I'm going to do 10 times 3 plus 6 times negative 5 plus 7 times 2. And that's going to be my first entry. Then I'm going to move on. I'm going to do row 1, column 2. So 10 times negative 2 plus 6 times 1 plus 7 times 5. All right, then I'm going to go to row 2, column 1. So 12 plus 25 plus 2. And then finally row 2, column 2, negative 8 minus 5 plus 5. Then all I got to do is simplify it. So that's 14. That's going to be 21. That's going to be negative 8. And then this last one's going to be 1439. All right, so now let's do a couple more examples. If you feel pretty comfortable, then you can go ahead and pause it and try this next one and the one after. But I'm going to go ahead and work these out. So first of all, this is a 3 by 2. This is a 2 by 1. So yes, they can get multiplied together. The result's going to be a 3 by 1. So again, I'm going to take first row, I'm going to take first row, first and only column. So I would do 12 minus 4. All right, then I'm going to go second row, first column, negative 20 plus 2. And then I'm going to go last row, only column, 8 plus 10. So I end up with a 3 by 1 with 8, negative 18, and positive 18. All right, so the last one, a little bit of a bigger one, but again, we're going to follow the same process. So first of all, 3 by 2 and 2 by 4. So yes, it's possible. My result is going to be a 3 by 4. So let's start at the top. So first row, first column. So this is going to be negative 3 minus 4. Then we go to, let's go and do the first row for all these. First row, second column. So that's going to be 9 minus 10. First row, next column, 3 plus 0. And then first row, last column, negative 9 minus 4. Okay, now we'll go down to the second row. All right, so second row, first column, so that's going to be 5 plus 2. We'll go first row, second row, second column, so negative 15 plus 5. All right, let's go second row, third column, so negative 5 plus 0. And then last one, negative 5 and negative 3 would be 15 plus 2. All right, then finally moving on to the bottom row. So we'll go bottom row, first column, so that's negative 2 plus 10. Bottom row, second column, 6 plus 25. Two plus 0. And then finally, last one. Let's do bottom row, last column. So -6 plus 10. But at this point, all I gotta do is just simplify all those values. So I'm gonna end up with -7, -1, 3, -13, 7, -10, -5, 17, 8, 31, 2, and 4. So that's it for matrix multiplication, addition, and subtraction. I'm going to do a lot more with matrices over the next couple days and look at how they start to relate to systems.